All right, so generative AI. It seems like it's everywhere these days. We're diving deep into it today, and you've sent us this presentation specifically for, like, non-tech leaders,
Mm.
which is good because this stuff can get pretty complicated pretty fast.
Definitely can feel overwhelming jumping into AI, but this presentation seems like a great place to start. Lays out the basics of AI in general, but then gets into generative AI and how it can be useful to, well, pretty much anyone.
Yeah. And you seem particularly interested in large language models, those LLMs everybody's buzzing about. I mean, the fact that they can actually generate, like, human quality text, it's kind of freaky.
It really is.
Hmm.
But it's not sci-fi anymore, right? We're already seeing them being used all over the place. I mean,
Okay.
automating content, translations, you name it.
Okay, so let's back up a sec. The presentation starts off by, defining what AI actually is, artificial intelligence.
Right. At its core, it's about machines, computers being able to simulate human intelligence.
Gotcha. And there are different levels of AI, right? The presentation mentions narrow AI, general AI, and even super AI. Are we talking like robot overlords here?
Not quite yet. Narrow AI, that's what we mostly have today. Basically, really good at specific tasks. Like, imagine a chef who can only make one amazing dish.
So, like Siri and Alexa, amazing at following instructions and answering questions, but not writing the next great novel.
Exactly. They operate within a set of, rules and parameters. But general AI, that's a whole other level. An AI that can perform A and Y intellectual task a human can do and adapt to new situations.
So, like a chef who can invent any dish imaginable, even dishes that don't exist yet.
Yeah, great analogy. But general AI is still mostly theoretical at this point. We haven't really cracked that code. Then there's super AI, which, well, that's the idea of AI surpassing human intelligence in every single way.
Okay, so we've got narrow AI doing its thing, general AI off in the future, and super AI as fuel for existential debates. But where does machine learning sit into all this? The presentation uses AI and machine learning kind of interchangeably.
Yeah, it can be confusing. Think of AI as the big picture, like the overall goal of creating intelligent machines. And machine learning, that's a specific approach to getting there, focusing on training algorithms to, learn from data and get better over time.
So AI is the car, machine learning is the engine that makes it go.
Perfect. And within machine learning, we have different types of models, generative, discriminative, and predictive. This presentation really dives into generative models, which is where things get, well, really interesting.
Right, generative models, the ones that can create new data based on, like, existing data, right?
Yeah.
So if you feed it a bunch of dog pictures, it could create a new dog picture that doesn't actually exist but looks real.
Yep. That's the idea. They learn the underlying patterns and structures in the data, and then, boom, they use that knowledge to create something totally new.
That is wild. So those generative models, those are behind generative AI, right? Which seems to be the hot topic in AI right now.
Definitely. Generative AI, it's taking those models and using them to create all sorts of new content, text, images, even music, giving machines that creative spark.
And the potential applications, well, the presentation mentions so many, from automating content to, like, developing new drugs to even personalizing education.
Yeah, the possibilities are kind of mind-blowing. It's not just about, cool visuals or catchy slogans. Generative AI could really transform industries in a big way.
Okay, so generative AI, it's a game changer. But before we go too deep, the presentation gets into two key technologies, large language models, LLMs, and neural networks. These are like the building blocks.
They are. LLMs, they're specifically designed to understand and generate human-like text, trained on massive amounts of text and code so that they can handle like a ton of different language-based tasks.
So things like chatbots that can actually hold a conversation, or translation tools that understand the nuances of different languages, or even AI systems that can write, different kinds of creative content.
All of that. Empowering all that are neural networks, basically complex systems of algorithms inspired by the human brain. They learn to recognize patterns and make predictions, all based on the data they're fed.
So neural networks are the brains behind LLMs, which are behind generative AI. It's like a chain reaction of innovation.
Yeah.
But how does it actually work? Like in practice, the presentation talks about models, training data, and algorithms. Are those the key ingredients?
You got it. The model is like the framework, defining how the AI processes information. Training data, that's the fuel, the massive data set that the AI learns from. And the algorithms are like the instructions, guiding that whole learning process.
Okay. Starting to see the bigger picture here. Then the presentation gets into different types of models, including GANs, VAEs, and transformers. Things are getting pretty technical now. Yeah.
Don't worry, we'll break it down. GNs, those are generative adversarial networks. Really good at creating realistic images. Basically, two neural networks going head to head. One generates data, the other tries to tell if it's real or fake.
So like an AI art competition. One network trying to fool the other with its masterpiece.
Exactly. And through that competition, they both get better and better until, well, the images are incredibly realistic.
Then there's VAEs, variational autoencoders. They seem to be more about like creating data that shares similar characteristics.
Right. VAEs are great for things like generating new faces that look real but don't actually belong to anyone. They basically encode data, compress it, then decode it, and create new data points in the process.
And lastly, transformers. They're the superstars of natural language processing, according to the presentation.
They're pretty amazing. A specific type of neural network that's changed how we process text, like think GPT-3, that's built on transformers. And it can generate some seriously human quality text.
Right. So we've covered different types of AI, the specific models behind generative AI. But this presentation, it really stresses the importance of high-quality, diverse training data. Why is that so crucial?
Well, imagine teaching a kid about animals by only showing them pictures of cats. They might think all animals are furry and meow. Same goes for AI. The more diverse the data, the better the AI can, understand and perform in different situations.
Makes sense, garbage in, garbage out. But even with the best data, how do we know if the AI is actually doing a good job? The presentation introduces something called evaluation metrics. Are those like the AI report card?
Pretty much. Evaluation metrics let us measure how well an AI is doing at its task and which ones we use. Well, it depends on the type of AI and what it's actually doing.
Gotcha. So let's talk about some of those metrics. The presentation really focuses on precision and recall, especially important for classification models. What do those actually mean?
Imagine a spam filter, right? That's a classification model. Precision tells you how many emails marked as spam are actually spam. Accuracy of those positive predictions. And recall, that tells you how many spam emails were correctly identified. So capturing as many real spam emails as possible.
So ideally, you want both high precision A and D, high recall, right? The spam filter catches all the actual spam and doesn't misclassify good emails.
Absolutely. But there's often a trade-off between the two. Increasing one might decrease the other. Finding the right balance, well, depends on what you're using the AI for and how much those errors actually cost.
It's like medical diagnosis. If a model is trying to diagnose a rare disease, high recall might be more important than precision. Even if there are a few false positives, because missing an actual case could be really bad.
Exactly. High stakes, gotta prioritize recall there. But in other situations, like, say, fraud detection, high precision might be more important, so you don't flag legitimate transactions as fraudulent.
So context is key. The presentation has this helpful table breaking down different precision recall combos and what to do in each case. Seems like a handy tool.
It is, and then it goes into real-world examples from all sorts of industries. That's where it gets really interesting.
Let's get to it then. Let's see how precision and recall play out in the real world. So precision and recall are key in all sorts of fields. But let's circle back to those large language models, the LLMs. The presentation defines those as like AI systems designed to understand and generate, human-like text. They're what's behind all these chatbots and content generators popping up everywhere, right?
Yeah, exactly. I mean, think about it. When was the last time you chatted with a customer service bot or used a tool to summarize a long article? Chances are you were interacting with an LLM.
It's kind of crazy how they can hold a conversation or generate different creative text formats, almost like they actually GET what the words mean.
Well, that's the goal, right? To build AI that can really grasp those nuances of human language. And LLMs, they're getting closer all the time, thanks to their massive scale and their sophisticated architecture.
The presentation mentions LLMs can have billions, even trillions of parameters. What does that even mean? Like a supersized brain?
It's more about the connections within that brain, In a neural network, parameters represent the weights and relationships between different pieces of information. More parameters basically means a more nuanced understanding of language.
So it's not just about the size of the data set. It's about how well the LLM can connect all that info in a way that makes sense.
Exactly. And that's what sets LLMs apart from those traditional AI models that struggle with natural language.
Hmm.
LLMs use deep learning architectures, specifically something called transformers. That's how they get such great performance.
Okay, transformers. Those are the game changers in natural language processing, right?
Yeah.
The presentation calls them like a type of neural network specifically designed for sequential data, like text. How do they actually work, though?
Imagine like a really attentive reader going through a sentence, word by word, but at the same time, paying attention to how each word relates to every other word in the sentence.
So not just processing words in isolation, but understanding the context and how they all fit together.
Exactly. And that's how they capture the nuances of meaning and can generate text that sounds so human-like.
The presentation mentions an encoder and a decoder. Are those the key players within a transformer?
You got it. The encoder, it processes the input text, and it creates this really rich representation of what it means, like capturing the essence of the message. And then the decoder, well, it takes that representation and uses it to actually generate the output text. Could be a translation, a summary, a response in a conversation, all sorts of things.
So encoder understands, decoder generates. Like a two-step dance of language processing.
Haha, a very elegant dance. And then there's this cool thing called self-attention that's happening inside the transformer. It basically lets the model focus on different parts of the input as it's processing each word.
Self-attention. So it's like the transformer is having a conversation with itself.
In a way, yeah. Self-attention lets the transformer figure out how important each word is in relation to all the others. It builds this dynamic understanding of the sentence.
Like when you're reading a complicated sentence and you have to go back and forth between different words to get the full meaning, the transformer's doing that internally.
That's a great way to think about it. And because it can capture those subtle relationships, transformers are awesome at things like translation and summarization, where understanding those nuances is so important.
Self-attention sounds pretty powerful. But the presentation also mentions multi-head attention. Is that like self-attention on steroids?
Something like that. Multi-head attention takes self-attention and runs it multiple times at the same time. So the transformer can focus on different aspects of the input all at once.
So it's like having a whole team of expert readers, each analyzing the text from a different angle, and then combining all their insights.
Exactly. This multifaceted approach means even more nuanced meaning and even more sophisticated output.
Okay, transformers, the brains behind the LLMs. Got it. But the presentation mentions these things called hallucinations. What are those?
Hallucinations. That's kind of the Achilles heel of LLMs. It's when they generate stuff that's, well, just plain wrong, factually incorrect nonsense, or just totally irrelevant to what you asked.
So the LLM is basically making things up, but making it sound believable.
Yeah, it's the tricky part. It might create a grammatically perfect sentence, sounds totally plausible, but, has no basis in reality.
Why does that happen? Is it like a bug in the system?
It's more about the limitations of the tech at this point. Sometimes LLMs get too focused on patterns in the data without really understanding the meaning behind the words.
So they might see the cat sat on the roof and predict Matt, because statistically it's the most likely next word, even if the sentence is actually the cat sat on the roof.
Right. They don't have that real-world knowledge, that common sense that we humans use to filter out nonsense.
Sounds a little concerning. Any way to, fix those hallucinations?
Researchers are working on it. One way is to improve the training data, make sure it's diverse and accurate. Another way is to add fact-checking, so the LLM can cross-reference its output with outside sources.
So give it access to, a giant library of knowledge to double-check its work.
Exactly. And user feedback is huge, too. The more users flag hallucinations, the better the models get at avoiding them in the future.
So it's a continuous learning process. The LLM gets smarter and more reliable over time. But it makes me wonder about transparency and explainability. How can we trust an AI if we don't know how it's making its decisions?
That's a really important point. Transparency is key to building trust with these systems. We need to understand how they're processing info and making choices, especially when they make mistakes.
Okay, so we've covered the good, the bad, and the hallucinatory parts of LLMs. But let's get back to the nitty-gritty of how they process text. The presentation actually walks through the journey of a sentence as it goes through a transformer. Ready to take that ride?
Let's do it. Let's say we give the transformer the sentence, "The quick brown fox jumps over the lazy dog." First step is tokenization. breaking the sentence into individual tokens, usually words, sometimes subwords.
So we get the quick, brown, fox, and so on.
Yep. Then each token gets converted into a numerical representation called an embedding. It captures the meaning and context of that word.
So like fox might have an embedding that's like 0.23, 0.56, 0.89, 0.12, a bunch of numbers that represent what fox means in the grand scheme of language.
Yeah, think of it that way. Words that have similar meanings or appear in similar contexts, they'll have embeddings that are closer together in this multidimensional space.
And remember, you said transformers use positional encoding too, to keep track of word order. So each word gets a little tag saying, like, I'm the third word or I'm the seventh word.
Exactly. Keeps everything in order, helps the transformer understand the structure of the sentence.
Right. Then it's off to the encoder, which processes those embeddings and positional encodings through, was it layers of self-attention and those feed-forward neural networks?
Yep. And that self-attention is working its magic, calculating those attention scores between words, figuring out how they all relate, creating like this dynamic map of the sentence's meaning.
Like a detective piecing together clues, connecting the dots to solve a case.
I like that. Then the encoder sends its output to the decoder, which takes that information plus any tokens it's already generated and starts predicting the NXT token in the sequence.
So if it's already generated the quick brown fox jumps, it's trying to figure out what comes next based on the whole sentence.
Exactly. And to prevent it from like peeking ahead and cheating, it uses masked self-attention, so the process is autoregressive.
Meaning it generates the output one token at a time, building the sentence word by word like a human would.
Yep. Keeps going until it hits a special end of sequence token, and boom, you've got your final output text.
Wow, that's a pretty detailed journey. This presentation actually has a really helpful diagram of the whole process. Makes it a lot easier to visualize.
Visuals are great for understanding complex stuff like this.
But how do we know how well these LLMs are actually doing? I mean, it's cool to see them generate text, but how do we measure if they're truly understanding language and being accurate?
That's where evaluation metrics come in. There are a bunch of different ones we use to assess LLM performance, and each tells us something different about what it can do.
The presentation mentions perplexity. That sounds, well, perplexing.
Haha, it can be. Perplexity basically measures how surprised the LLM is by new words in a sequence. Lower perplexity means it's good at predicting what comes next, which suggests a better understanding of the language.
So if it sees the sun rises in the rush and predicts east with high confidence, that's low perplexity because it's a predictable sequence.
Right, but if it sees the sun rises in the winter and predicts, I don't know, refrigerator with high confidence, that would be high perplexity. It means it's not really getting the meaning of the sentence.
Okay, perplexity makes sense now. And then there's accuracy. That one's pretty straightforward. Just the proportion of correct predictions the model makes.
The higher the better. And for tasks like classification, where you're categorizing text into different classes, we often use the F1 score. It's a way of balancing precision and recall.
Bringing it all back together, it's all connected.
It is. And for translations, there's the BLEU score. That compares the LLM's output to, like, reference translations made by humans, sees how closely it matches up.
So higher BLEU score means a better translation, more accurate, more fluent.
Exactly. And for summarization, there's the Roget score. Measures how well the LLM summary captures the key ideas in the original text.
Higher Roget, better summary.
Got it. And then there's throughput. That's all about efficiency, how much data the model can process in a certain amount of time.
So a high throughput LLM is a fast one. The presentation gives some fun examples that illustrate these metrics, like comparing LLM translations to human ones to show what the BLEU score means.
Yeah, those examples definitely help make it more concrete.
Okay, so we can measure how well LLMs understand and generate text, translate, summarize, even how fast they work. But there's one more really interesting topic in this presentation: prompt engineering. What is that?
Prompt engineering, that's the art of crafting those prompts to guide LLMs towards generating, the output you actually want, like giving them clear instructions and examples to steer them in the right direction.
So it's not just about asking a question, it's about asking it the right way to get the best response from the LLM.
Exactly. A well-crafted prompt can really make a huge difference in the quality of the output. Makes it more insightful, more creative, more relevant to the task.
It's like those choose-your-own-adventure books, where the reader's choices determine the story. Prompt engineering is choosing the right path for the LLM, guiding it towards a successful outcome.
Love that analogy. And the presentation breaks down different types of prompts based on, like, their structure, their purpose, their specificity. There are descriptive prompts that just state the outcome you want, instructional ones that give specific instructions, example-based prompts that show examples of the desired output, and even role-based prompts that assign the AI a specific role to play.
So if I want a poem about a robot, I can say, write a poem about a lonely robot yearning for connection. That's descriptive. But if I want a specific kind of poem, I could say, write a sonnet about a robot who falls in love with a human. That's instructional.
Exactly. And you can control how specific you are, too. You can have really open-ended prompts like write a story, or more specific ones like write a 500-word story about a time traveler who visits ancient Rome.
Right. And there's also something called shots in prompt engineering, right? That's about how many examples you give the LLM.
Yep. You can have zero-shot prompts where you give no examples, single shot where you give one, or few shot where you give multiple.
Wow, it's a whole science. Learning how to speak the LLM's language to get the best results.
It is. And as LLMs get more and more advanced, mastering prompt engineering is going to be key to unlocking their full potential. So let's look at how LLMs are being used in the real world. This presentation gives some really interesting examples.
Let's see them in action.
Well, translation is a big one, as we've talked about. LLMs are powering more accurate, more nuanced translations between languages, breaking down those communication barriers.
Content generation is huge, too. Writing articles, marketing copy, even generating code, LLMs are becoming these, versatile content machines.
And they're great at text summarization, taking long documents and condensing them into concise, informative summaries. Big time saver.
And, of course, question answering. Think chatbots that can answer your questions about, well, anything. Products, services, complex topics, whatever. And they're getting so good at having these natural, informative conversations.
The presentation also lists some of the big players in the LLM world. Llama by Meta, BERT by Google, GPT by OpenAI.
It's wild to see these powerful tools being developed by some of the, biggest tech companies out there. This deep dive has been so insightful, and I'm already thinking about how I can use these concepts in my own work. But I bet there's even more to learn.
Oh, there's always more. The world of AI is constantly changing, and LLMs are at the forefront. But I think we've covered a lot of ground today. You've got a solid foundation now.
Absolutely. So what does it all mean? We've gone from AI basics and machine learning to the nitty-gritty of generative AI, LLMs, transformers.
Yeah.
Quite a journey. But I keep thinking, if LLMs can already generate text that's basically as good as human-written text, what does that mean for the future of, content creation, communication, education?
That's the big question, right? The potential is both exciting and a little scary. We're moving into a world where machines can create and communicate, maybe even teach, in ways we used to think were uniquely human.
It's mind-blowing. Could we see LLMs writing novels, composing symphonies, teaching classes?
It's not impossible. And it raises all sorts of questions about, human creativity and expertise in a world where machines can do so much.
Definitely a lot to think about. But I think this deep dive has given us the knowledge and the tools to approach these questions in a smart way.
I agree. Who knows what amazing breakthroughs are coming next in AI? It's an exciting time to be part of this revolution.
Thanks for joining us on this deep dive into generative AI. We hope you found it insightful and inspiring. We've covered so much ground in this deep dive into generative AI, really explored how this technology works, from neural networks to those crazy transformers, and how those are what's powering those large language models.
Yeah, and we've seen how LLMs are already being used everywhere, right? Chatbots, content creation, translation, summarizing text.
But what really got me thinking is how generative AI could, transform whole industries. The presentation talks about drug discovery, personalized education. I mean, it seems like the sky's the limit.
It does, doesn't it?
Yeah.
I mean, think about how these advancements could change the way we work, the way we learn, even how we create art.
Speaking of art, I'm curious about the role of human creativity in a world where AI can generate such sophisticated output. Are artists and writers going to be obsolete?
A lot of people are wondering that, but I think generative AI, it's more about augmenting human creativity, not replacing it.
Yeah, I can see how it could be a powerful tool for collaboration. Imagine an artist using AI to brainstorm new ideas, or a writer using an LLM to get over writer's block.
Right. It's about using AI to enhance our own abilities, not to completely take over.
And it's not just about creativity either. The presentation makes a good point about how generative AI could help solve some of the world's biggest problems, like developing new drugs to fight diseases, or creating those personalized learning experiences for students.
The potential for positive impact is huge, But we also have to remember, like any new tech, there are risks and challenges that come with it.
Yeah, like those hallucinations we talk about, where LLMs generate, wrong or nonsensical output. That seems like a big obstacle.
It is, and it shows why we need to keep doing research, keep improving these systems to make them more reliable and trustworthy.
And then there's the ethical questions, right?
Yeah.
We need to make sure these tools are being used responsibly and that everyone benefits, not just a select few.
Absolutely. We have to have these open conversations about the ethics of AI and figure out guidelines for how to use it the right way.
So, as we wrap up this deep dive, what are the key takeaways? What should our listeners be thinking about?
Well, first, remember that generative AI is a really powerful technology. It's changing rapidly, and it has the potential to transform industries, solve big problems.
Second, there are definitely risks and challenges, but there's also this incredible potential for positive impact.
And finally, it's so important to approach generative AI with, a thoughtful and ethical mindset. Make sure those benefits are being shared with everyone.
This has been an amazing journey through the world of generative AI. Thanks so much for joining us and sharing your insights.
It's been my pleasure. I always enjoy talking about this stuff.
And to our listeners, we hope you found this deep dive insightful and maybe even inspiring. If you want to learn more, definitely check out the resources we've been discussing.
And keep in mind, this field is constantly changing, so stay curious, keep exploring, and who knows what amazing discoveries are waiting just around the corner.
Thanks for joining us on the deep dive. We'll catch you next time for another exciting exploration.